Welcome back. In this last video for this section, we will actually be doing a little bit of graphing of rational functions. We'll start with a nice, fairly straightforward one and then do some slightly more complicated ones after. This one is straightforward in the sense that it's given to us in factored form, so it's easy enough for us to find the simplest terms version of this rational function, 2x plus 1 over x minus 1 all squared. And right away we can start to identify some things. Namely, we have two excluded values, 1 and 3. 1 comes from the factor x minus 1, which is still here once I've put my rational function in simplest terms. So that means that we have a vertical asymptote of x equals 1 on our graph. The other part is that since we had 3 as an excluded value, and that came from the factor x minus 3 that we completely removed, then that's telling you that we have a hole on our graph when x is equal to 3. And of course we need to know what the y value is, so we put the value of 3 in for x into our simplified version of our function. And so we've got a hole at 3 7/4. So what we'll do now, just before we get too far into it, we'll start by graphing our vertical asymptote and our hole. So we've got it all plotted. So we have a vertical asymptote, x is equal to 1. And I'll plot my hole of 3 7/4. 7/4 is just a little bit less than 2, so I'm drawing that as a hollow circle, labeling it 3 7/4. There we go. And I'm going to do that as I do all of my graphs. As I get new information, plot it on my graph, and then we'll go back and pick up some more clues and then continue on. Okay, so we've talked about vertical asymptotes, we've talked about holes. Next part to talk about, of course, is horizontal asymptotes. And for that, we need to think about degrees of the top and of the bottom. At the top, you can see that the leading term here, of course, is just 2x, degree 1. And for the bottom, the leading term would be x squared, so degree 2. Since the bottom has the larger degree, yes, we do have a horizontal asymptote, and it's going to be the line y equals 0. Okay, so that means I should plot on my graph the horizontal asymptote y equals 0. Now when I do, I've got two options as to how I can draw it. One option is to draw my horizontal asymptote going all the way across from far left to far right. The other option, which is the one that I'm actually going to do, is to just draw my horizontal asymptote happening just on the far left and also on the far right. I think it's a nice idea to do this because, remember, with horizontal asymptotes, those only really come into effect at the extremes because horizontal asymptotes are about end behavior. That means that in the middle of our graph, we might cross through it once or twice or a bunch of places. It's only at the very far ends of the graph where we'll have to taper off to that horizontal line. So I think it's a nice way to remind yourself that yes, you can cross that horizontal asymptote in the middle of our graph, just making sure that we draw it only on the far left and far right. Okay, so back to our function again. We've got most of the information we need. The only things that are left are to figure out x-intercepts and y-intercepts, and then looking at if we need any extra points, and then going ahead and graphing. So to start with, the y-intercept part of things is easy enough. For y-intercepts, this is where we let the x value be 0. And to find the y value, we just need to put 0 into the simplified version of our function. And our y value is 1. So we have the y-intercept at the point 0, 1. And as far as the x-intercepts go, again, we can think about x-intercepts, where they are, the factor that gave us the x-intercept, what was the multiplicity, and what's going on at that x-intercept, what's the behavior. Looking back at our function, remember, x-intercepts only happen when the numerator is equal to 0, and the numerator is only ever equal to 0 when x is negative a half. So we have an x-intercept at negative a half, 0. And the factor that gave us that only was there once, so multiplicity was 1, and odd multiplicity means we're going to be crossing the x-axis. So now I'm going to plot those 2 points. I'll plot 0, 1. I'll plot negative a half, 0. I'll have to come back and label that point after. I'm going to wait until I've actually got my drawing completed, and then I'll do the labeling afterwards. Since I don't know exactly where the curve will be, I don't want to have it accidentally go through my labels. So we'll start by drawing some things here, starting with, for example, the y-intercept of 1. If you're thinking about making your way to that vertical asymptote, you have 2 options. You could either go up forever, become vertical in a positive sort of direction, or you could leave that that y-intercept and head downward. Of those 2 options, one of them is impossible. Going downward is impossible because that would require us to have an extra x-intercept, and we've already decided there is only one x-intercept, so too bad. That means that going down is not possible. This is what I mean by examining the options of what our graph could do and then ruling out the things that are impossible. When we leave that y-intercept, either we're going to go up or down. We've decided that going down is not possible, so we must be going up. So heading up and becoming vertical as we get closer and closer to x being 1. Once we leave that y-intercept, we're going to have to make our way to that x-intercept. And once you know that you're at that x-intercept, according to our behavior, we're supposed to cross that x-axis at that x-intercept. So I'm going to then take my x-axis and cross through it. Okay, so I've got a good start to my graph. I know that I'm going to be passing through that point, negative 1/2, 0. I'm going to hit my y-intercept and then head upwards and become nearly vertical. Now the question is, what happens after I've left that x-intercept? If you're thinking about options, one option is go down forever. And that we can say no to right away because we know that we have a horizontal asymptote. Once we get to the far right, far left, and far right of our graph, we'll be horizontal to the line y equals 0. So I guess we're not going down. Another option might be go up forever, and that's impossible for 2 reasons. That would mean that you'd need an extra x-intercept, which we don't have, and it also would mean that you don't use that horizontal asymptote. So 2 reasons why you couldn't go up forever. So that means the only other option is we're going to have to turn around eventually, and we're also going to have to become horizontal. So that means somewhere on the far left side of our graph there's going to be a turning point. As always, we're not going to know where our turning points are, so if you were looking at comparing my graph with a computer version of the graph, this turning point that I have, it looks on my graph like it's between -3 and -4. Maybe it is, maybe it isn't, and there's no way with the skills that we have in this class for us to be able to tell. So if your turning point looks like it's in a slightly different location, or your graph looks like it goes much deeper, all of those would be valid ways to draw this graph. Okay, last part to talk about. Don't forget that there's a right side of that vertical asymptote. So again, we're going to need to figure out what's going on over here. We do have some information. We've got that hole, 3 7/4. So using that, saying, well, when we leave that hole, either we're going to go up forever or we're going to go down forever. And which is possible? And the answer is it's looking like going down is not possible because that would require another x-intercept, which we know we don't have. So as we get closer to that vertical asymptote, we must be going up forever. As far as the far right goes, again, you couldn't be going up forever because that would ignore the horizontal asymptote. Going down forever would make you cross the x-axis and also ignore the horizontal asymptote. So again, that's not possible either. The only possible option then must be that we taper off to that horizontal line. And so there we go. We have got our graph of our function, and now the only thing left to do is to label it. One thing just to mention here, when we're labeling our function, we're going to label it with the original definition of it. So I'm going to label this as y equals x minus 3 times 2x plus 1 over x minus 3 times x minus 1 squared. So there we go. That's our function that we have. We've labeled every point that needs to be labeled. Oh, nope, I have not. I didn't label that x-intercept. Always good to double check to make sure that everything that needed to be labeled got labeled. Okay, now I feel good about that. The equation is labeled for the function itself, and my vertical asymptote and horizontal asymptote, those are labeled as well. And so there we go. This is my graph of our function g of x. Okay, let's do another one, f of x. This one is a little bit more involved. We're going to have to do some factoring. And it's not too bad to factor. Top, I'll take out a constant, take out a common factor of x squared. The bottom is a nice difference of squares, x minus 1, x plus 1. And then it looks like I can do a little bit of canceling of those x plus 1s. So it looks like in simplest terms, I'll have x squared times x plus 2 all over x minus 1. Okay, so we'll start with the usual business, thinking about vertical asymptotes, horizontal asymptotes, and holes. I'll start with the easiest ones first. Horizontal asymptote, I can say right away the answer is that there are none. And the reason there are none, and this is whether we're looking at the simplified version or the unsimplified version. In the unsimplified version, the degree of the top is 4 and the bottom has degree of 2, so top has the larger degree. And if you'd looked at the simplified version, the top has a degree of 3, x squared times x, and the bottom has a degree of 1, just x. So either way, the top has the bigger degree, which means no horizontal asymptote. As far as vertical asymptotes go, we do have one. The excluded value x equals 1. That came from the factor x minus 1, which is still there in our denominator after we simplified. So yes, we do have a vertical asymptote. And then finally, if we're thinking about holes, yes, we do have one, and that's because we had a factor, x plus 1, that gave us an excluded value of negative 1, and that factor was completely removed. So that means we will have a hole when x is equal to negative 1. And of course, we want to know what the y value is, and we use the simplified version of our function to figure out what the y value is. So putting in negative 1 for x, we'll get negative a half. So we will have the point negative 1, negative a half as a hole on our graph. Okay, so before we start thinking about x-intercepts and y-intercepts and all the rest, I'm going to go and put that hole and that vertical asymptote on my graph. So x equals 1. And also the point negative 1, negative a half, drawn as a hole. Again, I'm going to label that hole later on once I've drawn in my curve and I know where the curve will be. I'll just have to remember in the back of my mind that I still have some labeling to do later on. One thing that we'll need to now think about is x-intercepts and y-intercepts. So remember that for x-intercepts and y-intercepts are easy to find, and x-intercepts just require us to look at the numerator for our function. So for the x-intercepts, remember that the rational function only crosses the x-axis when the function is equal to 0, and that only happens when the numerator is equal to 0. And you can look and see that there are two values of x that make our numerator 0. So let's just make our list here of our x-intercepts. And of course, as always, we'll talk about our multiplicity and what that means as far as the behavior. So first x-intercept that we have comes from the factor x squared, and that would be an x-intercept of 0, 0. And that factor, x squared, shows up twice, so multiplicity of 2, which means that that x-intercept will be touching the x-axis, not crossing it. The other x-intercept that we have comes from the factor x plus 2, and that would be negative 2, 0. That factor only shows up once, so multiplicity of 1, which means we're crossing the x-axis. Another thing to notice here, as far as y-intercepts go, that x-intercept is also, of 0, 0, is also the y-intercept. So I don't need to do any extra work in looking for the y-intercept, since the x-intercept that I found already is the y-intercept. So I just need to plot my two x-intercepts, 0, 0, and negative 2, 0, and then start graphing. Okay, so we're getting ready to start thinking about graphing here, and one thing hopefully you'll notice is that on the left side of the vertical asymptote we've got some points, which is going to give us some information to work with, but on the right side of our vertical asymptote I don't have any points whatsoever. I have no clues to help me figure out what's going on that side, which means I'm going to need to take some sort of extra point or extra points to help me figure out what's going on. So what I'll do is I'm going to figure out a point on the graph for when x is equal to 2. And so to do that, I'm going to put in 2 for x and find out what the value I get for y needs to be. So putting in 2 for x tells me that my graph should have the point 216. So that extra point 216, I'll need to plot that on my graph. There we go. And now we're ready to go. I'm going to start with the right side of the graph. With this one, if we're thinking about options for that point, 216, you either are going to head up to the vertical asymptote and become vertical in a pointing up direction, or you're going to head to the vertical asymptote going downward and heading in the negative direction. Heading downward, of course, that's not possible because that would make us cross the x-axis, and we know we don't have any x-intercepts there, so that means as we get towards the vertical asymptote, we must be heading up. As far as what happens on the right side of that point, we could go down for a while, but we can't go down forever because that would make us cross the x-axis. We also can't start becoming horizontal because that would mean we have a horizontal asymptote, which we know we don't have. So once we're leaving this point and heading downward, we'll eventually have to turn around and start to head upwards. Remember, the only options for end behavior is to head up or to head down or become horizontal. And we've just said becoming horizontal is not possible, and also heading downward is not possible. So the only option is that on the far right, we're heading upwards forever. So our shape then is that we'll head up to the vertical asymptote, and as we leave that point, head downward and eventually turn around and come back up. As always, the turning point, we have no idea where it is or how deep it is, so it looks like I've drawn it kind of shallowly. You might draw it looking quite deep. It might look like the turning point is much further to the right than the way I've drawn it. All of that would be a valid way of drawing your graph. Okay, now to the left side of my vertical asymptote, I can see I've got these 3 points, and for sure, as I leave that hole, I'm going to have to make my way up to that x-intercept, and I'll also have to make my way up to that other x-intercept. So at least between the two x-intercepts, it's pretty clear what's going on there. When I leave the x-intercepts, this is where I'm going to start to think about my behavior that I have at them. Remember, we said at 0, 0, the multiplicity was 2 for the factor that gave us that, and so at 0, 0, we should touch the x-axis. So at 0, 0, I should touch the x-axis, which means it looks pretty clear. I'm heading downward forever. If I tried to turn around and go up, that would make me cross the x-axis, which is not possible. At -2, my behavior there was that I'm supposed to cross the x-axis. The multiplicity was 1, which meant we're crossing the x-axis. And so if we're looking at what's going on there, well, it's pretty clear I must continue to go up forever, because if I tried to become horizontal, that would mean I need a horizontal asymptote, which I don't have. And if I tried to turn around and go down, that would mean I'd need an x-intercept, which I don't have. So the only other option is to continue going up forever. So I'll just label that point, that whole -1, -1/2, and I still need to label my equation, so f of x there we go. We've labeled our function. We have labeled all of the points that need to be labeled, and there we go. That's a nice well-labeled graph of f of x. Okay, one last one to work on, and this is p of x. Again, I'm going to do a quick little bit of factoring here. For the numerator, I can take out x, which would leave me with x squared minus 4, which would factor as a difference of squares, x plus 2, x minus 2. On the bottom, if I were to factor out x, that would leave me with x squared plus x minus 12, which that also would factor out fairly nicely. That would factor out as x plus 4, x minus 3. And we can see that the x's would cancel. And so we've got a couple of things. Number one, we have two excluded values that are locations for vertical asymptotes. We have vertical asymptotes at x equals 3, and also the line x equals -4. We also have a hole that's in this graph. We have the excluded value x equals 0 from that factor x, and that factor x got canceled, so we'll have a hole when x is 0 and y is so this would be -4 over -12, which is positive 1/3. So we'll have a hole at the point 0, 1/3. As far as horizontal asymptotes go, again, remember that for horizontal asymptotes, you need to look at the degree of the top and of the bottom, whether it's in simplified form or not. And if I'm looking at the unsimplified form, the degree of the top and the bottom are the same. They're both degree 3, which means, yes, we do have a horizontal asymptote, and it will be the line y equals leading coefficient for the top over leading coefficient for the bottom. So the line y equals 1 will be our horizontal asymptote. Okay, so I guess I'm going to start by plotting those. So I'll put on my two vertical asymptotes, the whole and the horizontal asymptote. So vertical asymptotes, I had one of them at 3. So there we go, x equals 3. I've got another one at x equals -4. And I also had the horizontal asymptote y equals 1. And like I said before, I'm only going to draw that on the far right and far left of my graph because, you know, it's possible we might cross through it somewhere in the middle, and it's nice to be aware of that being a possibility. The other part that I still need to label is, or plot rather, is that whole that was at 0 and 1/3. So there's our whole. As always, I'll do the labeling of my points afterwards once I know what the function should look like. Okay, so we've already got quite a bit of information here, a couple of asymptotes, vertical ones and one horizontal. We still need to talk about x-intercepts and y-intercepts, and actually, if we're looking at this function, we can see, for what I've already plotted, there will be no y-intercept. Notice that here on the y-axis, we have a hole. So the hole is where the y-intercept would be. So actually, we don't even need to look for a y-intercept. We already know there won't be one. The only thing left to do is to talk about x-intercepts. And if we're looking at the numerator, you can see there are two values of x that will make the numerator equal to 0, 2 and -2. So if we're thinking about this, the x-intercepts, we have 2, 0, and we've also got -2, 0. Both of those factors that gave us those x-intercepts had multiplicity of 1, which means that both of those x-intercepts, you'll be crossing the x-axis. So I really only have two other things to plot here so far, which is my 2 points, the x-intercept 2, 0, and the other x-intercept -2, 0. This is enough to help me figure out what's going on in the middle of my graph. So you'll notice here that we've got 3 regions. We've got to the left of the one vertical asymptote, in between the vertical asymptotes, and then to the right of the other vertical asymptote. In the middle, we've got some points, so we could figure out what's going on there. But on the far left, we have no points whatsoever, so we'll need an extra point in that area. On the far right, we don't have any points, so we'll need a point in that area as well. So I'm going to go back and I'm going to find out what is the y value when x is 4. I'm also going to find out what is the y value when x is -5. And then we'll plot those points, and then that should be enough to get us to draw our function. So I'll do some extra points here. First one would be when x is 4. We can find out what the y value would be. So that would be 4 minus 2, 4 plus 2, over 4 plus 4 times 4 minus 3. So in the denominator, that would be 8, and 12 for the numerator. So we have 12/8, which is the same thing as 3/2. So we'll have the point for 3/2. That'll be one point that I'll need to plot. The other one will be when x is -5. I said that was the other x value I was going to take. And so if I put in -5 for x, that simplifies to give me on the top +21, and on the bottom +8. So we have the point -5 and 21/8. 3/2, that's 1.5. 21/8, that's 2.5-ish, a little bit more than 2.5. So I know roughly where to plot my points, and I'll come back and I'll label them after. So the 1 point, 4 and 3/2, or 4 and 1.5, so around there-ish. The other point was 5, negative 5 and 21/8, and 21/8 was between 2 and 3, so somewhere around there-ish. And now we've got our information that we'll need to graph our function. I'll start with the far right. So again, looking at this point that we just figured out, that point 4, 3/2, if you were heading towards that vertical asymptote, it's clear going downward is not an option because that would require you to have another x-intercept. So you must be going up. We also know that we wouldn't be going down forever and then tapering off to our horizontal asymptote because that would require you to cross the x-axis. We can't go up forever because that ignores the horizontal asymptote. So it looks like the only option here is to taper off to that horizontal asymptote on the right side. And same sort of things going on the far left. That point negative 5, 21/8. Again, if you were leaving it, you couldn't head down because that would head you to the x-axis and you don't have an x-intercept there. So you must be going up forever. And on the left side of things, you can't cross through the x-axis, you can't go up forever, because those would involve you having extra x-intercepts or ignoring your horizontal asymptote. It looks like the only option here is to just taper off again to that horizontal asymptote of y equals 1. Okay, so I'll label that point. All right, and so now the only thing left to graph is the middle of our function. And for this one, if I'm looking at the hole, it's pretty clear I'll have to leave that hole and get to those two x-intercepts. And if we scroll back, at both of those x-intercepts, we're supposed to cross the x-axis. And that kind of sets the scene nicely for how these are going to finish off. If we cross the x-axis and head downward, we can't cross again to the vertical asymptote because that would need a new x-intercept. So I guess we just continue going down and becoming vertical. And same thing on the other side. We must continue going down and becoming vertical because if we change direction, we'd need another x-intercept, which, again, we don't have. So away we go. We just need to label this function and then we are finished. So this was p of x, which was x cubed minus 4x over x cubed plus x squared minus 12. So there we go. We just have to label our equation and then we are finished.